So this is assessment, the second video on assessment number 6 on rotational dynamics. What we have is we have a turntable with a disc. The disc has a mass of 1.2 kilograms, a radius of 1.3 times 10 to the negative 1 meters, a frequency of 0.5 hertz, and it comes once the turntable is turned off. It takes 8 seconds for the disc to come to a complete stop. We're going to be finding a few things in this video. First thing that we're going to find is the initial angular velocity. We know, like I said, we know that the frequency is 0.5 hertz. The way we find the angular velocity or angular speed is by using the initial angular velocity is equal to 2 pi frequency, and so we have 2 pi radians per cycle, and then we multiply that by our 0.5 hertz, which is also our cycles over seconds, and we get that the initial angular velocity is pi over radians per second, or 3.14 meters per second. The second thing that we want to find is the angular, I think I wrote that wrong. We want to find the angular deceleration. Oh no, I have it right. Deceleration of the disk as it's coming to a stop. So we know that the disk has an initial angular speed of 3.14 radians per second, and we know that the final angular speed is going to be 0 radians per second. So to find the angular deceleration, we use cycloacceleration equals the change in angular velocity over the change in time. So we can also write that as the final angular speed minus the initial angular speed. We get the angular acceleration comes out to be 0 minus 3.14 radians per second divided by 8 seconds, and we get that the angular acceleration is negative 3.9 times 10 to the negative 1 meters per radians per second squared. The final thing that we want to find out is the angle at which the disk turns. We use the equation delta theta equals the angular speed initial delta t plus 1/2 the angular acceleration times delta t squared. All we simply do is plug in numbers, and so we have the angle equals to 3.14 radians per second times 8 plus 1/2 times negative 3.98 times 10 to negative 1 times 8 seconds squared. We get that the angle at which the disk turns is 12.64 radians. Like I said, this is our second video for reassessment number 6 on rotational dynamics.